Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic Disproportionation reactions. For links to other topics and question timestamps, please visit video description. Question 16. Chlorine gas is reacted with aqueous sodium hydroxide. The oxidation number of chlorine changes from 0 to -1 and also from 0 to +1. Under which conditions does this reaction occur, and what is the color of the solid silver salt with chlorine in the oxidation state -1? Let's write the reaction. We have two types of reaction. One is with cold dilute alkali. Second is with hot concentrated alkali. Now with cold dilute sodium hydroxide, the reaction will be like this. We have chlorine Cl2, sodium hydroxide, which is cold dilute. It will form sodium chloride, NaClO, and water. Now second reaction of chlorine is with hot concentrated alkali. Cl2 plus sodium hydroxide. It will form sodium chloride, NaCl, NaClO3 along with water. The oxidation state of chlorine in molecular form is 0. In NaCl it is -1. Let's find the oxidation state of chlorine in NaClO and NaClO3. We have one sodium, so it is +1, one chlorine, and one oxygen. Oxygen is -2, overall charge is 0. So chlorine -1 equals 0, chlorine equals +1. So the oxidation state of chlorine in NaClO is +1. In NaClO3 we have one sodium, one chlorine, and as there are 3 oxygens, so it is -6, overall charge is 0. Chlorine -5 equals 0, so chlorine will be +5. This is the oxidation state of Cl. As in the question it says it changes from 0 to -1 and 0 to +1, so therefore it means it is cold dilute alkali, not hot concentrated alkali. Now the color of silver salt with chlorine in the oxidation state -1. When chlorine is -1, the compound formed is AgCl, and AgCl is white precipitate. Correct answer is therefore A. Question number 14. Hot aqueous sodium hydroxide reacts with chlorine. Which statement is correct? Number A. The oxidation numbers of chlorine and hydrogen both change in the reaction. The oxidation numbers of chlorine in the products are -1 and +1. So let's see what are the oxidation states. Sodium is +1, oxygen is -2, hydrogen is +1, chlorine is 0 because it is neutral. Again sodium is +1, chloride is -1, sodium is +1. There are 3 oxygen atoms, so the overall charge is -6. So the positive charge should be +5. Water, oxygen is -2, so hydrogen is +1. Again there are 2 hydrogen atoms, so each hydrogen atom has +1. The oxidation numbers of chlorine and hydrogen both change. We see chlorine changes from 0 to -1 and 0 to +5. While the oxidation state of hydrogen is +1 on the reactant side and +1 on the product side. So both does not change, only oxidation number of chlorine is changing. So A is incorrect. B is the oxidation numbers of chlorine in the products are -1 and +1. It is, as we can see in sodium chloride, it is -1, but in sodium chlorate, it is plus 5. So it is not plus 1, it is plus 5. So this is also wrong. C part, if the aqueous sodium hydroxide is cold, the reaction produces NaClO instead of NaClO3. Yes, this is correct because chlorine, when reacts with cold sodium hydroxide, it produces sodium chloride along with NaClO and H2O. So C is correct. D. Sodium undergoes disproportionation in this reaction. Disproportionation basically means self-oxidation reduction. So in this reaction, basically chlorine is getting oxidized and reduced. So it is not sodium, it is chlorine. Question 36. Chlorine reacts with sodium hydroxide in two different ways depending upon the temperature. So there is a temperature difference between the reaction 1 and reaction 2. Which statements about these reactions are correct? Number 1. Reaction 2 requires higher temperature than the reaction 1. Let's see what type of reaction is this one. Actually, these reactions are the disproportionation reaction of chlorine. Disproportionation means self-oxidation and reduction. So in these reactions, chlorine is oxidized and reduced at the same time. So it says reaction 2 requires a higher temperature than reaction 1. This is correct because in reaction 2, chlorate ion is being produced, which is produced from hot alkali. So reaction 1 occurs in cold alkali, while reaction 2 occurs in hot alkali. Part 2. The products of reaction 1 show chlorine in two different oxidation states. This chlorine is -1 and this one is, we can find the oxidation state of this chlorine, ClO, overall charge is minus. We know that oxygen is -2 and overall charge is -1. So chlorine -2 is equal to -1. Chlorine is equal to +2 -1. Chlorine is equal to +1. So chlorine is actually +1 in this compound. So there are two different oxidation states. So this is also true. Third one says the product of reaction 2 shows oxygen in two different oxidation states. Now we can find the oxidation state of oxygen. In water, the oxidation state of oxygen is -2, and in chlorate ion, ClO3-, the oxidation state of oxygen is still -2. It is not changed, so therefore this one is incorrect. So the answer is B. Question 17. The reaction of bromine with warm sodium hydroxide aqueous produces products with the same oxidation numbers in the same ratios as the reaction of chlorine with hot sodium hydroxide. In one reaction between bromine and warm NaOH, 30.2 grams of product containing sodium, bromine and oxygen is produced. Which mass of sodium hydroxide has reacted? They have given a hint of disproportionation reaction in which chlorine reacts with hot sodium hydroxide. So the reaction of bromine will be the same and the molar ratios are also same. So we can write the balanced equation. As in hot alkali, chlorine reacted with sodium hydroxide to form sodium chloride, sodium chlorate, and water. The molar ratios in balanced equation were 3, 6, 5, 1 and 3. The reaction of bromine will be similar, so we can write for Br2, 3 moles of Br2 will react with 6 moles of sodium hydroxide to form 5 moles of sodium bromide along with sodium bromate and 3 water molecules. Now we can see that in the question they have given 30.2 grams of product which contains sodium, bromine and oxygen. So it is this one. The mass is 30.2 grams. Which mass of sodium hydroxide has reacted? So we have to find out the mass of sodium hydroxide. Let's take the ratio between them. We have sodium hydroxide and sodium bromate. According to balanced chemical equation, 6 moles of sodium hydroxide form 1 mole of sodium bromate. Let's find the number of moles given in the question. So we have mass which is given as 30.2 and molecular mass of NaBrO3 will be, it is 23 for sodium, 79.9 for bromine, and for 1 oxygen it is 16, so for 3 oxygen it will be 48. So the total molecular mass of sodium bromate is equal to 150.9. We can find the number of moles as moles is equal to mass in grams divided by molecular mass. So mass in grams is 30.2 and molecular mass is 150.9. So number of moles are 0.2 moles. We can put this value in the ratio given. So we can write 0.2 moles of sodium bromate is formed from X moles of sodium hydroxide. So by cross multiplying, X is equal to 6 into 0.2, which becomes 1.2 moles of NaOH. Now in the question they have asked about the mass. So mass is equal to moles into MR. For sodium hydroxide, we have 23 for sodium, 16 for oxygen, 1 for hydrogen. So in total the molecular mass comes equal to 40. So we can write 1.2 for number of moles and 40 for molecular mass. So mass in grams come equal to 48. The answer is therefore D. Question 35. Chlorine reacts with hot, aqueous sodium hydroxide. Which oxidation state does chlorine show in the products of this reaction? The equation of this reaction is Cl2 plus hot sodium hydroxide. It forms sodium chloride, NaClO3 which is sodium chlorate, and H2O. Now let's find the oxidation state of chlorine in the product. We have NaCl, so the oxidation state is -1 for chlorine. For sodium it is +1. In NaClO3 we have 1 sodium which is +1, chlorine and 3 oxygens. Overall charge is 0. So Cl becomes +5. So we have -1 and +5. +5 is not given. As only option 1 is correct, the answer is D. Question 35. 3 samples of chlorine gas each contain 0.710 grams of chlorine. Each sample is reacted with a reagent. In the first reaction, a sample is reacted completely with hydrogen gas. In second, it is reacted completely with cold sodium hydroxide. In third, it is reacted completely with hot sodium hydroxide. Which masses of the named products would be formed? Let's first write the balanced chemical equation. For first reaction, we have hydrogen gas, chlorine gas. It will form HCl. Now we can see that in balanced equation 1 mole of chlorine forms 2 moles of HCl. Now we can find the moles of chlorine by using this mass, and the molecular mass of chlorine is 71. So dividing mass divided by molecular mass, number of moles of chlorine come equal to 0.01 moles. Now if 1 mole of chlorine forms 2 moles of product, then 0.01 mole of chlorine will form double amount of product. So it will be 0.02 moles of HCl. Let's convert this number of moles into mass. The molecular mass of HCl is 1 for hydrogen, 35.5 for chlorine. So overall we have 36.5. Mass in grams is equal to number of moles into molecular mass. Putting values, number of moles is 0.02, molecular mass is 36.5. So it comes equal to 0.730 grams. Now in option 1 we can see that exactly 0.730 grams of HCl is formed. So option 1 is correct. Now doing the same for second reaction, the reaction is between chlorine and cold sodium hydroxide. Balanced equation will be like this. As in the option they have given NaCl, so we are concerned only with sodium chloride. In balanced equation we have 2 moles of sodium hydroxide being reacted to form this product. Now we can see that the ratio of chlorine with sodium chloride is 1:1. So it means 0.01 moles of chlorine will form 0.01 moles of sodium chloride. Now converting this moles into mass, the atomic mass of sodium is 23, for chlorine it is 35.5, so in total the molecular mass becomes 58.5. Mass in grams is equal to moles into molecular mass. Moles is 0.01. Molecular mass is 58.5 for sodium chloride, so it comes equal to 0.585 grams. In option 2 we can see that exactly 0.585 grams of sodium chloride is formed, so therefore this is also correct. Now option 3, chlorine is reacted with hot sodium hydroxide. Now the product formed will be like this. In the balanced equation we have 3 moles of chlorine that react with 6 moles of sodium hydroxide to form 5 moles of sodium chloride and 3 moles of water. So now the ratio between chlorine and sodium chloride is 3:5. As we have 0.01 moles of chlorine, so x moles of sodium chloride will be formed. By cross multiplying we can find the value of x. So now the number of moles of sodium chloride come equal to 0.01667 moles. The molecular mass of sodium chloride is 58.5. Converting these moles into mass, mass is equal to moles into mR. The answer comes equal to 0.975 grams. In option 3 exactly same mass is given, so therefore 3 is also correct. As all 3 options are correct, the answer is A. Question 17. Chlorine reacts with both hot and cold sodium hydroxide to form products containing chlorine. Cold sodium hydroxide forms sodium chlorate X and hot sodium hydroxide forms sodium chlorate Y. X and Y are oxidation numbers. Which equation is correct? Now we know that with cold and hot sodium hydroxide the reaction is like this. With cold sodium hydroxide, chlorine forms sodium chloride, NaClO, and water. With hot sodium hydroxide, chlorine forms sodium chloride, NaClO3 and water. We can find the oxidation state of chlorine in both NaClO and NaClO3. Sodium is +1, oxygen is -2, overall charge is 0. So the oxidation state of chlorine is +1 and this is sodium chlorate X. Then we have sodium chlorate Y. Sodium is +1, chlorine is Cl, we have 3 oxygen atoms. Overall charge is 0. So the oxidation state on chlorine is +5 in sodium chlorate Y. So we can say that X equals +1, Y equals +5. So we can say that +5 equals +1 +4. So C seems to be the correct option. Thanks for watching. If this was useful, please do like, subscribe and share.